We pick up with a problem similar from yesterday. A rectangle is inscribed in a semicircle, radius 16. What dimensions of the rectangle, what dimensions should the rectangle be in order to maximize the area of the rectangle? Well, I'm going to draw a semicircle here. And we'll kind of try to piece it together. What y value does it cross through up here? 16. What's the x value over here? And how about this value? How do you know it's 16? Because the radius is 16. So what I have is a rectangle that's inscribed on the inside. Now, here's where it's really important that you stay disciplined. What is the objective? Maximize area. This is what will drive the problem right here. So I write an expression for area. What is the area of a rectangle? Base times height. At this point, it would be nice if we could simply just take the derivative and solve and set it equal to 0. But we have two variables. We have two unknowns, b and h. This is the point which requires the aha moment, where you have to say, oh, I see what I can insert in to help me out. Okay? So let's just kind of go with it here. Base is equal to what? 2x height is equal to y. So now we have area is 2x times y. That looks better than the b times h. At least it's related to x and y. But I still have a problem. I need to get rid of what? The y. Right. And so this is, well, you could go ahead and get rid of the x. That will be fine. The thing is, I'm very confident about the 2x written as the base. And the fact is, maybe the height could be written in relation to the base. So that's why I'm going to try to get rid of the y. So this is where it has to come to you. Yes. Do you know the formula for a circle? That's the area. Do you know the equation for a circle? So that's what has to occur to you. And if that doesn't occur to you, what I would do is I would go down and complain to the office about the college algebra teacher you had last year, because he was obviously pretty bad. But that's the equation for our circle. If that didn't occur to you, Skylar Hansen, she set up a triangle. She said, well, if this is x and this is y, this is 16. So you get x squared plus y squared is 16. It's the same thing. The equation for a circle is the Pythagorean theorem. X squared plus y squared is 256. Doesn't matter how you think of it. Either way, that's what we've got. So I can model problems like that for you all day, and I know you can do them. The hope is that at some point you come up with that moment on your own. Okay? And so that's why I really want you to try 10 and 11. I think that those are reasonable problems. That's it. I'll help you out if you can. So we've got x squared plus y squared is 256. Can I solve for y? I can. X squared, let's see, y squared is equal to 256 minus x squared. Square root both sides. And we get y is equal to 256 minus x squared. We may not take the square root of each. Plus or minus would be correct, yeah, but since it's the top half of the circle, we'll keep the positive version of it. We can't do this. Square root of 25 minus 16 is equal to 5 minus 4, which is 1. That's not true, because square root of 25 minus 16 is the square root of 9, which is 3. So can't do that, right? So we just can't take square root of each piece. So that's voodoo math. Okay, So the equation, now I can plug this in. The area in terms of what variable will I express this in? X is equal to 2x times the square root of 256 minus x squared. Take the derivative. How do you do that? Product and chain. Very good. A prime of x. So you ask yourselves, why did we have to learn how to take all those derivatives? Because in real life applications, sometimes you come up with difficult derivatives. Derivative of 2x, 2. Square root of 256 minus x squared. Hey, I'm halfway there. Plus 2x, 3/4 of the way there. Now, what do I have to use? Chain rule. I'm running out of room, so I'm going to do it over here. Derivative of, let's see, I got u to the 1/2, huh? 256 minus x squared. Derivative of u to the 1/2 over 2 roots of u. And then derivative 256 minus, yep, negative 2x. So you can see that the 2's will cancel, become negative. So we get a times a negative x over the square root of 256 minus x squared. We gotta set this piece equal to what? 0, because that's where a maximum will occur or a minimum will occur. If it was times, you could, but it's plus, so you can't. Instead, I'll set it equal to 0, and what I will do is I will choose to find common denominators. What is the common denominator? So when I multiply the top and bottom by the root of 256 minus x squared, that will go away, right? So I get 2 times 256 minus x squared, and then there's a minus 2x squared all over the root of 256 minus x squared. Am I concerned about where the denominator is equal to 0? No. Where is the denominator equal to 0? 16 and negative 16, right? Well, look at your problem. Does it make sense that 16 and negative 16 wouldn't really be reasonable solutions? Yeah. What? You have a question? Okay. So we have this. I will now solve the numerator equal to 0. 2 times 256 is 512. 2 times negative 2x squared is negative 2x squared, minus another 2x squared is negative 4x squared. Or 512 is equal to 4x squared. Divide both sides by 4. X squared is equal to 128. X is equal to the square root of 128. 64 goes in there, so 8 roots of 2. Which is 11.31. I would accept either or on the test. Does that answer my question? What's the question? Dimensions. I need dimensions. So, what is the base? Times 2. So, 22.62 or 16 roots of 2. I'll write it both ways. How do we come up with the height? Where? Yeah, so if I take this 11.31 and I plug it in right here, this is what tells me what y is. You plug in x, you get y. And what you end up with is 11.31 or 8 roots of 2. That's how it works out. The question is, what are the dimensions? And we
we've given the dimensions. Go ahead, Quinn. Yeah, so the base, I had to double the x value, and so I doubled either one of those. In order to find the height is y, so it says y is equal to this, so I plug in for x. And I don't plug in the 22.62, I plug in what x was, which was 11.31. Okay? All right, so what do you think about that? Not bad, huh? Okay, so what we've done so far is we've covered all problems that we had last year. How about we get to something new, right? I know you're eager, right? You're getting bored. Haley's like, I can do these problems in my sleep. Please give me something that will give me a challenge, Mr. Gens. Thank you very much, right? I hear you. So, this one says, find the equation for line tangent to the curve f of x equals 2x minus 6x squared minus x to the third. Something you have not seen before, something that's a little bit more legitimate. So, I don't know where to begin with the problem, so I draw 4 boxes, because that helps get me on track. And I start with modeling the problem. I will model it. What does that graph look like? Yeah, does it start down and go up, or does it start up and finish down? It starts up and finishes down. Why? Because it's a negative x to the third. Very good. So as I look at this shape, you tell me, well, what's driving the problem? What's the objective? Largest slope. Well, maximize the slope, right? You tell me when I get to the point where I have a maximum slope, where the slope is at its largest. Yeah, what point is that? Inflection. So, I'm going to show you 2 ways to try to figure that out. Number one, you just saw what I did. I drew it, and I pointed that spot, and we see it's the inflection point. But second of all, I want you to think of this. Largest slope. What do we do in calculus to find the slope? The derivative, right? What do we do to find the largest of something? What have we done lately? In order to maximize something, we take the derivative, we set it equal to 0. So look at what the words are saying. You are finding the largest slope, the derivative of the derivative. What is the derivative of the derivative? It's the second derivative. How do you find inflection? It's the second derivative. See how those pieces are connected? Okay? That's what it's stating. So, our equation is very simple. F of x is equal to 2x minus 6x squared minus x to the third. What we want is we want an equation for the slope. Because it says find the largest slope. What do I do to find an equation for the slope? Find the derivative. What is the derivative? 2 minus 12x minus 3x squared. Good. Now, this is my slope formula. I would like to find the largest slope. I would like to maximize the slope. So I have to take the derivative of the slope function. What's the derivative of the slope function? Good. 0 equals negative 12 minus 6x. That would be the second derivative. That is what will tell me how to maximize the slope. Where is this function equal to 0? X is equal to negative 2. So, the problem asks to find an equation for the line tangent. What 2 things do I need in order to find an equation for the line tangent? Good. I need my slope, and I need a point on my line. We already know the point on the line is negative 2. Oh, I don't know the y value. How will I figure out the y value? Which one? Do I plug it into the second derivative, the first derivative, or the original? The original. Plug in negative 2. It's negative 4 minus 6 times 4 minus negative 8. Negative 4 minus 24 plus 8. Negative 20. What do I find? gotta find that. Over negative 2 into the first derivative for a slope function. Over 2 plus 24 minus 36 minus 12 is 14. And now we have 24 to 21. 1 plus 20. So the slope I would get from the first derivative. So I took negative 2 and plugged in the first derivative. So y plus 20 is equal to 14 times x plus 2. I think I like that part. I said that was different from all the elements I'd seen before. That was different. I feel the same way, don't you? All right. Second derivative, because you're asking a great question. We're trying to find the largest slope. In order to come up with a slope function, I take the first derivative. In order to find the largest slope, I try to maximize that derivative. How do we maximize the derivative? We take the derivative instead of equal to 0. So the language here says we take the derivative. Largest means we take the derivative. That's what we're doing. When it says maximize, we take the derivative. Slope also means derivative. So that's why we take the second derivative. We'll be able to set this first one up and we'll take a break for lunch. We weren't able to quite get through it last hour. We kind of fell apart at that point, but we got through most of it. The class was split half and half. Some of you stay late and see it all the way through. I said we won't get through it full far because usually we don't show on time full far just because of lunch. But again, we'll finish on tomorrow with the main class, and then we'll have a full work day. But these two are great ones. The first time I taught this class, I showed them problem number 7, and I had an anarchy in my head. Like, there's no way that we could be expecting to do problem number 7. And I understood their fear and frustration. And I held my ground and I said, don't worry. If you can't do it, that's the measure of the master of the art. And they hated that I said that. I said, I'm sorry. I said, if you're really in the class, figure it out. And you know what? When it happened, we figured it out. And this board the exact same thing. Find the equation for the line 3442 that cuts off a triangle from the first quadrant with the smallest. Okay, find it there. Okay. We'll do it together. What do we do first? How do you fix it? What's your name? First quadrant. Excellent. First quadrant. Boom. 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 Finally, good idea. Who should do first? Put the point on it. We're not done. We're not done yet. No. You're not it says it cuts off a triangle. I don't know how else it would know. Exactly. Exactly. So she sees the issue here. The goal is to write on the page in front of you, right? What two things you need to write in front of you? So I can point that out. Write point out, but we gotta find the slope. Amen. All right. Leave us a brain for come back excited. You're awesome.
Okay, here we go. So we've got our